On slide 36, I return to the topic introduced in the prologue, namely the relationship between positive affect and tiredness. We saw an inverse relationship between those two outcomes, tiredness in blue and positive affect in red. And we asked if tiredness follows cycles due to a circadian 24-hour rhythm, and we asked if such cycles also affect positive affect. And we've studied positive affect now, both in terms of the observed sum score and in terms of factors, and find that there are these cycles also for positive affect. And we're ultimately interested in then the relationship between tiredness and positive affect after accounting for the cycles. Is there something else in positive affect than just not being tired? As a first step in that then, let's take a look at an analysis using the 2A approach. Namely, modeling cycles and having fixed cycles coefficients. Now this is for tired only, so this is a univariate analysis, just like we started off with a univariate analysis for positive affect. And we do this in a cross-classified DSEM setting, just like we did before in step 2A. And what you're looking at here is a plot of the cycles in these consistent curves across time, and the between time estimates, which are sometimes a little higher, sometimes a little lower than the cycles themselves. So for instance, on Saturday here, it seems like these individuals are less tired, low value on tiredness, than predicted by the cycles. So they are perky adolescents midday on Saturday, much more so than the cycles curve predict. And we see then that we have a very tight relationship between the two curves, and it's reflected in a high R-square value of 0.73, whereas R-square for the positive affect was only 0.41. So focusing on the main topic then of the epilogue, we are going to use a two-level RDSEM based on the two factors that we have found and relate that to cycles and to tiredness. So it's a bivariate analysis of PA and tiredness, but building it on top of a two-factor analysis like before here, for the 6 items and the 2 factors. So this is a two-level model. So we have within here, I don't show the between model. Here are the 2 factors. Here is the tiredness within component. And here is the observed tiredness variable. So it's very much like slide 5, where we looked at this model for an observed PA variable, the sum of the items. But in this case, instead we have the 2 factors. And then we have the cycles variables, x1 and x2, which influence tiredness and influences the factors as well. And we have, for simplicity, no random cycles coefficients here, no filled circles. And also, for simplicity, we are not going to involve any time invariant covariates like in the previous analysis in step 5. Although we could add them for the between level parts of the factors, so F1B, F2B, and tired B, that is the between part. But we haven't done so in this analysis. So you look at this picture then, you see then we have a residual coming into tiredness and the residual coming into F1 and to F2. And we're asking if what's left in tiredness after we've taken out the cycle's influence, after we've counted for that, what's left, does that influence the residual in the two factors after accounting for for the cycles in those two factors? So it's a residual relationship that we're looking at here, going this way and going that way. A little intricate drawing here, but this is in line then with slide 5, except that we generalized it to a two-factor situation. Here's the input. The left-hand side looks the same pretty much as it looked for the two-factor analysis in run 5A. And we have the same number of B iteration, 25,000. I don't think it's quite needed here for two reasons. Because we're doing two-level RDSEM instead of cross-classified analysis. And also we're not having random cycles coefficients, but actually fixed cycles coefficients. So let's take a look at the details of the model here on the right. So you have the first factor, the low arousal factor for PA, measured by the low arousal items. And then the second factor, the high arousal factor, specified in the same way as before. So ampersand 1 being a sign that we can use lagged effects for these two factors. Further down here in the model, we set the metric in the factor variances, we regress the factors on the cycles variables, and we also regress tiredness on the cycles variables. So now what's bolded here then is what's of primary interest. We use the hat notation to regress the residuals of the two factors on the residual of tiredness. So the residual in the regression of the factors on the x1, x2, and the residual of tiredness regressed on x1, x2. Just in line with the model figure that I showed on the previous slide. So that's the key relationship that we're interested in. Is there any relationship there? Is there any significant influence of the tiredness variable taking out the cycles on the factors taking out the cycles? And then you have an autoregression here, like before, for the factors and also for tiredness. On the between level then, we have two between level factors once again. And the question is once again whether that's really needed or if we should just have a single factor here. I'll speak to that in a second. And we regress those two factors on tiredness here, thinking that tiredness is a predictor, relevant predictor also on the between level. And here's where we could add time invariant covariates influencing both the factors and tiredness if we wanted to. So here then is what we found. Excerpts from the output in standardized form. So on the within level, here is the residual for the low arousal PA factor regressed on tiredness. Significant effect in the sense that the confidence or credibility interval does not include 0. It's negative. It's a small effect. Whereas if we look at the high arousal factor, we have quite a much larger effect. So that tiredness does have a significant and strong effect on the factors, or at least the factor of the high arousal kind, being excited and the like. So here we see a strong difference then between the factors. They're clearly, the fact that there are two factors is validated by this influence from tiredness, where tiredness has a very small effect on the low arousal, but a stronger effect on the high arousal factor. So yes, Positive affect measures something beyond tiredness, especially the low arousal factor does. Tiredness doesn't have much influence on that. Now on the between level then, we have the factor 1 and factor 2, and very similar relationships here, very similar coefficients. And that then asks the question, or sort of answers the question, that these two factors are not really different, at least not with respect to the tiredness influence. So that's just like in step 5, where F1b and F2b had similar influence from the time invariant covariates.